number 8, f of x is equal to the natural log of x plus 1. F prime of x, remember it's just going to be the derivative of x plus 1. Well, what's the derivative of x plus 1? The derivative of x plus 1 is 1 over x plus 1. And that's it for that. What about the next one? What about f of x equals the natural log of 4x squared minus 6x plus 3? Well, then f prime of x is equal to, remember the derivative of the natural log of a function? The derivative of the function, which is going to be 8x minus 6 all over the function, 4x squared minus 6x plus 3. And that's all we're doing with that one too. What about number 10? Number 10 is x minus the natural log of x, all of that cubed. Remember, the very outside function for this one again is that cubed function. So we start off with that general power rule. So this guy here comes and multiplies out in front. So f prime of x is equal to 3 times, copy paste, x minus the natural log of x, raise it to 1 power less, so 3 minus 1 is 2, times then the derivative of the inside. Well, what's the derivative of x? The derivative of x is 1. What's the derivative of the natural log of x? Well, the derivative of the natural log of x is the derivative of the x, which is 1 over x. And again, that's it for number 10. Let's keep going with the next one. We have the natural log of x plus 1 over x. Now for this one, we're going to have to use our quotient rule. The numerator, or the top, is equal to the natural log of x plus 1. And the bottom is going to equal x. So the derivative of the top, t prime, is going to be, well, the derivative of the natural log of x plus 1 is the derivative of x plus 1, which is 1 over x plus 1. The derivative of the bottom, so the derivative of x, is equal to 1. So recall, f prime of x is going to equal the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So f prime of x is going to equal the bottom, which is x, times the derivative of the top, which is 1 over x plus 1, minus the top, which is the natural log of x plus 1, times the derivative of the bottom, which is 1, all over the bottom, which is x squared. And again, you can just go ahead and leave it like that. No need to clean any of that up. All right, number 12. Number 12 says to find the equation of the tangent line at x equals 6 and also find the values for where the tangent line is horizontal. So there's two things going on here. First, I want the equation of the tangent line at x equals 6. So anytime I see equation of tangent line, I start off by taking the derivative. Now this has a square root in it, so I really want to rewrite it first. So f of x is equal to x times 2x squared minus 8 to the 1/2 power. And x times, so I know that that's a product. So let's go ahead and label the first and the second here. So I'm going to say that f, or my first, is x. And s, or my second, is going to be my 2x squared minus 8 to the 1/2 power. So now the derivative of the first, the derivative of x is 1. And the derivative of the second, s prime, well, this is going to be my general power rule. So that comes out and multiplies out in front. So 1/2 times, then we copy paste 2x squared minus 8, raise it to 1 power less. Well, 1/2 minus 1 is -1/2, times the derivative of the inside, and the derivative of the inside is going to be 4x. And for this one, let's go ahead and simplify, because when you have to do something within a product and then find equations of tangent lines and everything else, it's going to be best to simplify this. So if I want to simplify it, I know that half of 4x is going to end up being 2x. So I end up with s prime is equal to 2x times 2x squared minus 8 to the negative 1/2. So the derivative f prime is going to equal the first times the derivative of the second, which is 2x, times 2x squared minus 8 to the negative 1/2, plus the second, which is 2x squared minus 8 to the 1/2, times the derivative of the first, which is just 1. And let's try to clean this up as much as possible. F prime of x is going to equal, now here, this guy here has a negative exponent, right? So it can go to the denominator, and then x times 2x is 2x squared. Here, anything times 1 is itself, and I'm going to go ahead and make that 1/2 back into a square root. The last thing I'm going to do to help clean this up is I'm also going to make this guy back into a square root. So this is going to be 2x squared over the square root of 2x squared minus 8 plus the square root of 2x squared minus 8. We're going to leave it like that for right now. We're trying to find the equation of the tangent line at x equals 6. So that means I'm going to have to plug in and find f prime of 6. So if I'm trying to find f prime of 6, which is going to be my slope, I would write 2 times 6 squared over the square root of 2 times 6 squared minus 8 plus the square root of 2 times 6 squared minus 8. And we're going to grab a calculator and do that. We have parentheses for my numerator, 2 times 6 squared, close the parentheses for my numerator, divided by square root of 2 times 6 squared minus 8. And then we need to add that to the square root of 2 times 6 squared minus 8. Hit enter, and I end up with 17. So the slope of the tangent line is 17. Now remember, in order to find the equation of the tangent line, what I'm going to have to do is I'm going to have to also find what the value of y is. And since I'm running out of space, I'm going to try to find the value of y over here in the left-hand corner. And then we'll find the equation of the tangent line. Now remember, y is going to be whatever f of 6 is, which means I'm plugging 6 into my function here. So it's going to equal 6 times the square root of 2 times 6 squared minus 8. And if we grab the calculator to figure that out, we would end up with 6 times the square root of 2 times 6 squared minus 8. And we get 48. So the y value is 48. So then, to find the equation of the tangent line, we would say y minus y1, which is 48, is equal to m, which is 17, times x minus x1, which is given as 6. So we get y minus 48 is equal to, okay, let's go ahead and distribute our 17. So 17x minus 17 times 6 is 102. Add 48 to both sides, and I get that y is equal to 17x minus 54. The next portion of the problem is asking us to also find the values of x where the tangent line is horizontal. So remember, anytime we're asked to find where the tangent line is horizontal, that means that we are looking to figure out where is f prime of x equal to 0. So this is where the tangent line is horizontal. So we need to set that first derivative. Remember, we got that first derivative to equal this, which is 2x squared over the square root of 2x squared minus 8 plus the square root of 2x squared minus 8, and set that equal to 0. Well, one of the things that we could do is we could multiply everything by the denominator to clear the fraction, which means I'm going to be multiplying everything by the square root of 2x squared minus 8, multiplying this by the square root of 2x squared minus 8, and then multiplying 0 by the square root of 2x squared minus 8. Well, here, my square roots of 2x squared minus 8 cancel, and I'm just left with 2x squared plus, here the square root of 2x squared minus 8 times the square root of 2x squared minus 8. Well, since it's identical, the square roots will cancel, and it's just left with 2x squared minus 8. And then 0 times anything is still 0. Combine like terms on the left, 4x squared minus 8 is equal to 0. Solve for x, add 8 to both sides. I get 4x squared is equal to 8. Divide both sides by 4. I get x squared is equal to 2. And then finally take the square root of both sides to solve for x. And we end up with x is equal to plus or minus the square root of 2. So that means that the values of x, where the tangent line is horizontal, is at positive square roots of 2 and at negative square roots of 2. Example 13 is also asking to find the values where the tangent line is horizontal. So in order to do that, again, we need to figure out where is f prime of x equal to 0. So first we need to find the derivative. Well, if I look at this, this is a quotient. So let's go ahead and label the top x to the fourth, the bottom 3x minus 8 squared. So now the derivative of the top, t prime, would be 4x cubed. Now b prime would equal, well, the 2 comes out in front. We're using that general power rule, times copy paste, so 3x minus 8. All of that raised to 1 power less, so 2 minus 1 is the first power, and I don't need to write that. And then times the derivative of the inside, well, the derivative of that inside is 3. But we can go ahead and clean this up because we know we'll have to. So 2 times 3 is just going to equal 6 times 3x minus 8. We're going to leave it like that. We're not going to go much further than that. So now we know that f prime of x is going to equal the bottom, which is my 3x minus 8 squared, times the derivative of the top, which is 4x cubed, minus the top, which is x to the fourth, times the derivative of the bottom, which is my 6 times 3x minus 8. And this is going to be all over the bottom, which is 3x minus 8, quantity squared, all of that, quantity squared. So now what we want to do is we want to do our best to clean this up because we are going to have to solve it because we're trying to figure out what values of x give us tangent lines that are horizontal. So the first thing I want you to notice is that we can pull out some like terms here. So since this is all multiplication, this is considered a term and this is considered a term. So if you factor out the greatest common factor from those two things, right, your greatest common factor is going to be, well, between the numbers 4 and 6, you can pull out a 2. Between x cubed and x to the fourth, you can pull out an x cubed. And from a 3x minus 8 squared and a 3x minus 8 to the first power, you can pull out a 3x minus 8 to the first power. If you pull all of those things out from this first step, well, if you take 4x cubed and 2x cubed, you know you're left with a 2. And if you only take out one 3x minus 8 and you had 2, you're left with a 3x minus 8. And then minus, if you take 2 from a 6, you're left with 3. If you take an x cubed from an x to the fourth, you're left with an x. And if you take a 3x minus 8 from a 3x minus 8, that cancels right out. And this is going to be all over 3x minus 8. Now power to power, we multiply our exponents, so 2 times 2 is 4. And then we might notice right now, hey, we can cancel one of these 3x minus 8s. So we're going to go ahead and do that. So f prime of x right now is going to equal 2x cubed all over 3x minus 8 to the third. And then let's go ahead and distribute and work with what's inside of those parentheses. In here, if I distribute my 2, I get 6x minus 18 minus 3x minus 16 minus 3x. I apologize. So 6x minus 16 and then a minus 3x. And then if we combine those like terms, f prime of x is going to equal 2x cubed times, from these two, we end up with 3x minus 16. And you don't want to simplify it any more than that, because in order to solve this, we'd have to factor. And if we distribute all this stuff together, then we're going to have to factor it at the end anyway. So now what we want to do is we want to set this thing equal to 0 and solve for x. So I'm going to say 2x cubed times 3x minus 16 all over 3x minus 8 cubed is equal to 0, and I want to solve it for x. Well, I can put my 0 over 1 and cross multiply. So if I multiply 1 times 2x cubed times 3x minus 16, I get 2x cubed times 3x minus 16. And if I multiply 0 times 3x minus 8 cubed, I get 0. Well, I have a product equal to 0, so I know that I'm allowed to set each one of these factors equal to 0 and solve them both for x. Here, divide by 2, and then take the cubed root of both sides, and I just get that x is equal to 0. Here, add 16 and divide by 3, and I get x is equal to 16/3. So the two values of x for which you get a horizontal tangent for this function are at x equals 0 and at x equals 16/3. That's it for section 3.4.